Question 2, Part A. The diagram shows the points A, -1, 3, and B, 2, 0. The line L is drawn perpendicular to the x-axis through the point B. Part 1. Calculate the length of the interval AB. Using the two-point distance formula to find the length of AB, we have AB squared is equal to 2 minus -1 in brackets squared plus 0 minus 3 in brackets squared. That is x2 minus x1 in brackets squared plus y2 minus y1 in brackets squared. And we get AB squared is equal to 18. Taking the square root of both sides to make AB the subject, we get AB is equal to the square root of 18 units, or 3 root 2 units in simple surd form. Part 2. Find the gradient of the line AB. Working from left to right, the gradient or slope of interval AB is equal to the change in y divided by the change in x. And that equals 0 minus 3 in brackets divided by 2 minus -1 in brackets, which equals -3 divided by 3, which simplifies to -1. Therefore, the gradient of AB is -1. Part 3. What is the size of the acute angle between the line AB and the line L? To find the acute angle between AB and the line L, we find the angle of inclination of AB to the positive x-axis, subtract from that 90 degrees, and we get the acute angle that we're after. So inverse tan of -1 minus 90 degrees is equal to 135 degrees minus 90 degrees, which equals 45 degrees. Therefore, the acute angle between AB and the line L is 45 degrees. Part 4. Show that the equation of the line AB is x plus y minus 2 equals 0. The gradient of AB is -1, which we found in part 2, and point B, 2, 0, lies on AB. So we have a point, we have a gradient. So using the point gradient formula, y minus y1 is equal to m times x minus x1 in brackets to find the equation of the line through AB, we get y minus 0 equals -1 times x minus 2 in brackets. Expanding the brackets on the right hand side, we get y equals -x plus 2. Then moving the terms on the right hand side over to the left hand side, so the coefficient of x is positive, and that way we get the equation in general form. We get x plus y minus 2 equals 0. Therefore, the equation of AB is x plus y minus 2 equals 0 as required. Part 5. Copy the diagram into your writing booklet and shade the region defined by x plus y minus 2 less than or equal to 0. Choose a suitable point either above or below the line, and using the coordinates of that chosen point, check if the inequality x plus y minus 2 less than or equal to 0 is true. And if it is true, then you shade the region that contains the point that you've chosen. Now I'm going to choose the origin, and I'm going to test if the origin lies in the region to be shaded by checking the inequality x plus y minus 2 less than or equal to 0 is true if x equals 0 and y equals 0, since they are the coordinates of the origin. So substituting 0 for x and y on the left hand side, we get 0 plus 0 minus 2 less than or equal to 0. Now 0 plus 0 minus 2 is -2, and -2 is less than or equal to 0. So because it's true, we shade the region below the line through AB. And here is a sketch of the graph, x plus y minus 2 equals 0, with the region under the line shaded, represented by the capital letter R. Part 6. Write down the equation of the line L. The line L is a vertical line through the point B with coordinates 2, 0. Hence the equation of line L is x equals 2. Part 7. The point C is on the line L such that AC is perpendicular to AB. Find the coordinates of C. AC is perpendicular to AB, hence gradient AC times gradient AB is equal to -1. Now the gradient AB is equal to -1, which we found in part 2. Hence gradient AC times -1 is equal to -1. Solving this equation for gradient AC, we get gradient AC is equal to 1. Now the point A, -1, 3, lies on AC. Since we have a gradient and a point, we can use the point gradient formula to find the line through AC. So the equation of AC is given by y minus 3 equals 1 times x minus -1 in brackets. Expanding the brackets on the right hand side, we get y minus 3 is equal to x plus 1. And then moving the -3 on the left hand side over to the right hand side and collecting like terms, we get y is equal to x plus 4. I'm going to call this equation number 1. Now the line through AC intersects with the line L at point C, hence the x-coordinate of C is 2. From equation number 1, the y-coordinate of C is given by y equals 2 plus 4. So I've substituted 2 for x here. So 2 plus 4 is equal to 6, so the y-coordinate of point C is 6. Therefore the coordinates of point C are 2, 6.